Okay, cool. So we have a rule for multiplying powers of the same base. What about dividing? Well, there are a lot of ways that we can get to this, but I think that the easy way is to remember that division is just multiplication in a silly hat. Let's say we have a quotient of 2 powers of x. Now, I made a rule that x can't be 0. Why? Because it's showing up in the denominator of a fraction. Okay, well, we can rewrite this, can't we? As x to the m times the reciprocal of x to the n, right? That's just what division is. It's multiplication by the reciprocal. Oh, but check this out. 1 over x to the n, that's x to the opposite of n. Yeah, division. It's just multiplication in a silly hat. This is x to the m plus negative n, using my rule for multiplication. So it's x to the m minus n. Okay, what if you don't like that? What if you would rather think about this just in terms of pretend division is a real thing? We can get this just in terms of natural number exponents, right? We have x to the m over x to the n. Let's see. Well, that's x times x times x times dot 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 times x m copies, or x times dot 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 x n copies. Oh, one of two things is going to happen here, right? Either m is the smaller number or m is not the smaller number, right? If m is the smaller number, well, we've got m copies in the numerator. In the denominator, we can split that up as m copies, and then what's left is a further however many extra copies we need to get up to n. That's going to be n minus m copies. Okay, well, this is a common factor of the numerator and denominator. We can cancel that out, and we've just got the n minus m copies left in the denominator. So this is 1 over x to the n minus m. So that's x to the negative n minus m. Well, okay, the opposite of n minus m, that's negative 1 times n plus negative m. Distribute, that's negative 1 times n plus negative 1 times negative m. That'll be negative n plus m. Using the commutative property, that's m minus n. So this is x to the m minus n. If m is not smaller, then when we have our m copies in the numerator and our n copies in the denominator, we can split up the numerator into n copies, and then whatever else I need to make up to m, that must be m minus n copies. And then in the denominator I just have my n copies. These are a common factor of the numerator and denominator. In the denominator all I have left is 1. So I've got m minus n copies of my number x. So x to the m minus n. We can see it just by rewriting the division as multiplication, or we can see it by keeping the division as division. Regardless, for any real number x that is not 0, and integers m and n, x to the m over x to the n equals x to the m minus n. Just to see an example of this, if I take 2 to the 4th over 2 to the 6th, that should be 2 to the 4 minus 6, so 2 to the negative 2. 2 to the 4th is 16, 2 to the 6th is 64, 2 to the negative 2 is 1/4, and 16 64ths does in fact equal 1/4, canceling a common factor of 16.